Okay, hey everybody, this is day 5 of your star review videos, and we're going to be on page 16, but first we want to go backwards to page 11, because I purposely skipped one to see if you were watching your videos. So if you were one of the ones that came up to me and said, hey, you know you skipped one, well, yeah, you caught me. So, good, I know you're watching. Okay, so this is back on page 11. And here's the question. It says, at the 8th grade dance, students can purchase snack items, equally priced, or get a photo package. Well, one of them, one person buys 2 snacks. Okay, this is price. So I used P for price because S looks like a 5. I don't want it to look like a 5. So 2 snacks, equally priced, and 1 photo package for $15. The other person bought 3 snacks, and then a photo package at $12, and it says they spent the same amount. So this is a pretty easy one to solve. Again, I'm going to look with my variables first, knowing that I don't want to have a negative variable. I want to get rid of this one by subtracting 2p over here. So that takes that one away. Leaves me 1p, which is just 1 snack. And that's going to make the last step pretty easy, because once I take away the 12 on this side and the 12 on this side, I get an answer of 3 over here. So every snack was $3. I do want to check it just to make sure. So if you bought 2 snacks for $3 a piece, 2 times 3 is $6, plus the $15 photo pack gives you a $21 total. And over here, 3 snacks at $3 a piece is $9, plus $12 photo pack is also $21. So they both spent $21, and they both bought snacks that cost $3 each. That's C on that one. Okay, so let's go back to the page we're doing today, which is on page 16. Again, that's where we're starting today, and hopefully this will be a pretty quick one. Again, we're on day 5. Okay, in the figure below, we got 2 lines that are parallel, and then we got this line that cuts through here called a transversal. And again, when that happens, we create a bunch of angles, but there's only really 2 different measurements. All the obtuse angles are going to be the same, so these 2 will be the same as these 2, and all the acute angles will be the same, so these 2 will be the same as these 2. So it says if the measure of angle 3, which is coming in here, is 47 degrees, what is the measure of angle 5? Well, this acute angle and this obtuse angle have to add up to 180. So to solve this one, I simply subtract the 47 from 180. I get 133, and then you would bubble this one in, 1. I put it in the wrong spot, look at me, 133, 133, ignore that mistake. I would erase that if I had a pencil, but you wouldn't see this very well if I was using a pencil. So, alright, number 2, triangle ABC is shown below. If the measure of angle ABC, now again, when you read these, you just go in order. So angle ABC. So ABC is this angle right here. They're saying this one is 52 degrees. And the measure of angle CAB is 64. So CAB, that's this angle right here. So that one's 64. And they want us to figure out the measure of angle BCR, which is this one right here. This obtuse angle. Now there's 2 ways to do this. One of the rules would be to find this angle, because all 3 of these have to add up to 180. Okay, so whatever this one is, when I know that these 2 also have to add up to 180, so then I can just subtract 180 minus this answer, and that'll give me this angle measurement. Okay, so that's one way. But if you remember our very easy rule, is when you have a straight line, right here, this is 180 degrees, and you have a triangle sitting on top of it, whatever these 2 angles are added together is what this one's going to be. So I already know that this is going to be whatever 52 plus 64 is, which is 116. So I know it's that one, but let's check the other way. So if I add up these, they get 116. So if I want to find this missing one down here, I subtract 116 from 180, and I get 64. And as you see, 64 and 116 is 180, so that is definitely my answer. And that would be an isosceles triangle, because 2 of them are the same. Okay, number 3, point A and B are shown in the graph below. What's the distance between the 2 points to the nearest tenth? Okay, so I need to find the distance of this line right here. But again, I can't just count that. I could count lines that go straight up, or lines that go left and right, but I can't count a diagonal line. Okay, that's when we have to use our Pythagorean theorem. So this distance right here is 4. Okay, 1, 2, 3, 4. This one is 2, 4, 5, 6, 7. Okay, and we just did this recently in class. So hopefully you know that you take those two numbers and you square them. You get 49 and 16. Since you're looking for this side here, which is our C, or our hypotenuse, or our diagonal, but it's definitely the longest line, I'm adding these two numbers together and getting 65. And then all I have to do to get the answer to that length is find the square root of 65. Well, hopefully you remember the square root of 64 is 8. So this is just a little bit bigger, so we're going to estimate it's 8.1. And when we look here, we see that that answer would work perfectly. All right. Okay, next page, number 4. Triangle ABC and DEF are similar because. Okay, well, so let's look at them. Well, the angles are the same. These two are 110, these two are both 30. And if these two are the same on both of these, that means these two also have to be the same. And even though that is enough to prove that these two triangles are similar, they have the same angle measurements. Doesn't matter how long the sides are, they are similar. But let's just check these answers here because they have more than just that. So it says the corresponding angles are congruent. Yes, that's true. The equal length, equal size, that's what congruent means. And the ratio of corresponding side lengths are proportional. Well, that is the true one. Now, there's another one down here that looks a little bit like it. This one says the corresponding angles are proportional. So this proportional does not mean equal. So that's going to be why those two don't work. But we want to look and see why H isn't correct. So it says the corresponding angles are congruent and the ratio of corresponding side lengths are congruent. Well, when we do ratios, those aren't something you call congruent. Again, congruent means equal length. A ratio is not a length. So that's why that word makes that a mistake. So we're going to pick answer F for that one, and that's the answer. Okay, number 5, another Pythagorean theorem question. It says a ladder that is 26 feet long leans against a building. Okay, this is a leaning ladder. Doesn't go straight up, it's leaning. And it says the bottom of the ladder, which is here, is 7 feet away from the base of the building. So here's the base of the building. So that tells us this is 7. You can see my beautiful building here. And they're going to ask us how far up the side of the building does the ladder reach. So they're talking about this distance right here. So again, Pythagorean theorem, my two sides are 26 and 7. I always write the bigger one first. And I might need to get the calculator out here, even though I know 26 squared. It's just to show you what you would do. That would work. 26 times 26, which is 676. Okay. And then 7 squared is 49. And then I remind myself that I'm looking for a smaller side than 26. This one has to be longest. So my next step is subtraction. So I get an answer of 625 when I do that. And I need to find the square root of that. Unless, well, I got one number wrong here. Sorry. Should have checked my work with the calculator. 676 minus 49 is 627. My fault. So 627 for that. And then I see over here that they are going to do that right here. So if they have it already in this form, that's okay to answer that, okay? Because that's whatever you would get, 20 whatever it is. We're like close to 25, I think, but that's how you would do that. Okay, triangle ABC and CDE are similar and are shown on the coordinate plane below. So we got this triangle and this little one here. Which of the following shows a proportion comparing the rate of change in y values to the change in x values of the similar triangles along with the slope? Okay? Now, if you look at all these slopes, they're all different. So if I just find the slope of one of these, I'm going to have my answer. Now, the fact that it's going this way should tell me immediately that my slope is negative. So that means it can't be this one. And I don't think that's a negative sign. Can't be that one. So then I just got to do rise over run. So to get to this point, I'm just going to do this one. I go up 3, 4, 5, 6. And then I go left 1, 2, 3, 4. So I rose 6. I ran 4. I already know it's negative. And when I simplify that to 3 over 2, I see that F is my answer. And I do want to make sure they did the sides correctly. So AB and BC, again the lights went out. Come on, lights. Let there be light. Thank you. Woo, that's bright. So, again, AB is this one, BC, so they went left side and base. And on this one, they did CD and DE, so left side and base. So it's definitely answer F. Okay, next page. We'll make sure I didn't skip one. Nope, I didn't skip any. Okay. Don't want to do that again. But again, I did that on purpose. All right, number 7. We've got, it says, which figure can be placed along the segment labeled X millimeters to match the model, to make the model a correct representation of the Pythagorean theorem. Okay, so here, if I zoom in a little bit, I got 10 and 10, and again, these are squares, so the area of this square is 100. I got 6 and 6 here, which means the area of this square is 36. Again, I'm trying to imagine what the area of this square would be, and if I just do 100 minus 36, I see that it's 64, and hopefully you know that an 8 by 8 square would produce an area of 64. So all I got to do is look down here. I see that right there. It's answer A. Okay, number 8, Ms. Lane has a square piece of paper, square, that measures 10 inches on each side, 10 and 10. She cuts the paper along the diagonal. There's the diagonal, my little cut marks, forming 2 right triangles. What is the length of the hypotenuse of each right triangle? So we're trying to find this. Okay. So again, my 2 sides, they just happen to match on this one, so I'm going to be doing 10 squared and 10 squared. Please be careful. If you got to put this in the calculator to not accidentally say 20, please do that. 10 times 10 is 100. And I'm looking for the longest side, so that tells me add these 2 numbers together, which gives me 200. So to get my final answer, I need to find the square root of 200. Since it's not a perfect square, we're doing a rounding to the nearest tenth. Okay, and that tells me it's probably not going to be a whole number. So when I come over here, again, to do this in your calculator, you hit the second button, then the square root button, which is here, because again, this does, and again, yours is blue, and on yours, mine just is yellow. Yellow gives me the square root symbol. 200 is what I'm trying to find the square root of. My answer is 14.14, which I'm going to round to 14.1. I look over here, and that is answer circle. That's H. Okay, number 9, which measure could be the side lengths of a right triangle? So again, if they give you 3 side lengths and they say, could this be a right triangle? Well, if you square all those numbers, take the small 2 ones and add them add them together, see if they equal the big one. If they don't match it perfectly, then they are not a right triangle. So I'm going to do 6 squared here is 36, 12 squared is 144, 10 squared is 100. I take the 2 small ones, 36 plus 100 is close to 144. It's 136. It has to be exact, so it's not that one. Now, since this one has decimals in it, for now I'm going to skip it. I'll go back to it if I have to do it, but I'm going to skip that one. Let's do this one here. 13 squared is 169, 14 squared is 196, 15 squared is 225, and you should see there's no way that those 2 add up to that one, so it's not this one. Well, now I do have to do the ones with the decimals, so I'm just going to do that. 8 squared, I'm going to write this down here. 8 squared is 64. 6.4 squared is 40.96, and 4.8 squared is 23.04. So 23.04 and 40.96. Now, if those 2 add up to each other, then I have my correct answer. So 23.04 plus 40.96 is exactly 64, which it's supposed to be, and that is my answer. And the last one, it's got the sailboat sailing, so it says that Kylie sailed this way 48 miles, then this way 14 miles. So far she's gone 62 miles. And we're trying to find out how far she sailed in all on Friday. So we got to find our C here. Okay? So as I know to do, I take the 2 numbers, I square them, and I put them in the calculator, or at least the first one. I don't know 48 squared off the top of my head. So 48 squared is 2,304. 14 squared is 196. So I add those 2 together and I get 2,500. And that's actually a pretty easy square root. It's exactly 50. Okay. So if I look over here and I see the answer 50, well, I might accidentally circle that unless I check to make sure I read it correctly. She went 62 miles when she went this way, then she went another 50. So 60 plus 52 means she went a total of 112 miles. So answer H. Okay, there we go. Day 5 of your 2015 STAAR review. Day 6 will be coming over the weekend. Y'all have a good one. All right, bye.